So what is an even number? And I'm sure most of you probably know this, but if you don't, which is fine, I want to give you a nice simple definition. An even number can be split into two equal groups of whole numbers. So it has to have a 0, a 2, 4, 6, or 8 in the ones place. And when I say whole numbers, what I mean is if you try to do 35 divided by 2, you'll say, oh yeah, but I could do 17 and a half. Well, okay, again, that's not a whole number, yeah. 17 and a half and 17 and a half does make 35, but we have a leftover, a remainder. It needs to be just the whole number, in that case, 17. So some examples might be 22, 46, 190, 2,158, or 531,794. As you can see, all of them have an even number in the ones place. So notice this number has all odd numbers, 5, 3, 1, 7, 9, but none of them really matter because we're only looking at the ones place. If the ones place can be divided into two equal groups, so it ends in a 0, 2, 4, 6, or 8, then we would have an even number, no matter what the other digits are. So what is an odd number? Odd numbers can't be broken into two equal whole number groups. So it has to have a 1, a 3, a 5, 7, or 9 in the ones place. So some examples, I've got 61, 423, 84,265, 7, and 942,379. Notice they all have a 1, 3, 5, 7, or 9 in the ones place. And when we add two even numbers, we will always get another even number, because anytime you add 2, 4, 6, 8 with another 2, 4, 6, 8, or 0, it continues to stay even, and all that really matters is the ones place. So for this example, if we had 12 plus 14, why are they always even? As I stated before, all that really matters are these units, right? So I've got 2 and I've got 4, that's going to give me 6. Anytime I'm adding 2, 4, 6, 8, or 0, 2, 2, 4, 6, 8, or 0, which all that matters is that ones place, right? What I add in the ones place, any regrouping goes to the other one, but I'm going to leave an even number in the ones place again. So it's going to be even. Done. So what about when we add two odd numbers? So 11 and 15 are both odd. Are we going to end up with an even or an odd number? Well, you would think odd. I know a lot of people say, well, it's odd because odd plus odd would be odd. Well, that's actually not true. Basically, anytime you add two numbers where both of them are either even or odd, it's not one odd, one even, they're both even or they're both odd, you're going to end up with an even number. And here's why. Let's look at the ones place. 1 and 5 gives you 6. Okay, if you had 1 and 7, you'd get 8. If you had 1 and 9, you'd get 10. If you had 3 and 5, you get 8. If you had 3 and 7, you get 10. Notice all those odd numbers plus another odd number gives you an even number. So another way I could show this is drawing 11 and 15 as 11 dots and 15 dots. And so I would circle pairs of 2 because that shows it can be broken into two equal groups. And I notice 11 has 1 left over. But so does 15. It has 1 left over. Okay, so I've got all these groups of 2 and then 1 left over. Well, when I combine that leftover and that leftover, I'm going to end up creating a new pair of 2 and having no leftovers. So is it true every time we add two odd numbers, we're going to get an even number? Yes! So here's where we get to an odd answer, an odd sum. We have to have an even number and an odd number, or an odd number and an even number. But we can't have two even numbers, and we can't have two odd numbers. Why? Because the even number is not going to leave any leftovers. The even number is going to have equal sets of 2. So this would be, the 10 is going to be canceled out because we know that's 5 sets of 2. But then we have these 2 and these 2, no leftovers. But you're going to notice I got this one scraggly leftover over here that's going to end up in my answer, right? Because 4 plus 1 is going to be 5. And 5 is odd. 5 cannot be broken into two equal groups. I get 2 and I get 3, or I get 3 and I get 2. I can't get two equal whole numbers. These are the only options. So every time I add an even and an odd number, I'm going to end up with an odd number. Which, of course, if you pause and read this, it says, what if the first number is odd and the second's even? Doesn't matter. Doesn't matter, right? Commutative property. It says that no matter what order my add-ins are in, I'm going to get the same sum, right? So whether it's odd first and even second or even first and odd second, bottom line is I'm going to have a leftover because of my odd number. My even number is not going to have any leftovers, so it's going to be odd. So if I stated that the product, so now we're dealing with multiplication, not addition, right? The product means to multiply of two even numbers is even. Is that always going to be true? That is correct. I hope you answered yes. I can't really hear you, but if I was a magician. Anyway, I mean, let's look here. We've got some even chances. This is a 2 and a 6, a 4 and an 8, a 2 and an 8. I'm sure no matter which way I do, my final answer is going to have an even number in the ones place. But this is where things change when we change operations. Now we're doing multiplication. When I have two odd numbers, what do you notice? That's right, the products are odd. So multiplying odd and odd gives me an odd number. But when I multiply even and odd numbers, of course in any order, because the commutative property, I end up with an even number. Interesting. And of course, here's the visual model. When I have even times odd, I end up having sets of 2 of something, because any number that's even is able to be broken into 2. And I just have this many sets of it. So that means I'm not going to have any leftovers because I'm going to have equal sets of an even number. I'm going to have a whole number group of sets of a whole number. So it works out. But odd and odd, leaving me leftovers, is I'm going to have an uneven or an odd number of sets of an odd number. So I'm going to end up with something left over. And then with even times even, I'm going to have an even number of sets in an even number of times. So it's not going to change the fact that it's still even. So to summarize the whole lesson, you really want to make sure you understand and memorize this if you don't already know it. But that when we're adding, even and even is even, odd and odd is even, but odd and even makes odd. In multiplying, even and even is even. Odd and even is even, but odd and odd makes odd. So there's some interesting things there. I'll come up with some sort of mnemonic device or song or some way to remember it. But that would let you come down here to the problem set and look at these right away and say, okay, I've got even and I have odd and I'm adding. This is going to be odd. Right, because 6 and 1 is going to be 7. I'm multiplying an odd and an even and an odd, so this is going to be even. I'm multiplying an odd and an odd, so this is going to be odd. I'm adding an even, this is going to be even. And look at all these even. I've got even, odd, 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 even. This is where it gets interesting. This is where we realize that I can take all my evens, 1, 2, 3. That's going to give me an even answer, right? And if I add my odds, 1, 2, 3, that's going to be odd. I say even. Because this and this will cancel out. This and this will... Oh, no! I think it's going to be odd. And it is odd because I fixed the issue. 3 even and 3 odd would be an odd of each, leaving me an even and an odd. So when I add odd and even, I end up with odd. Good thing I took my time and checked. All right, have a good day.